Hello everyone. Hope you are enjoying your journey in this exciting course on cloud computing. Nowadays, we are hearing the buzzword big data everywhere. The market is forecasting on millions of opportunities for big data professionals. In this video session, we will explore the concept of big data. We will also go through what is big data, a few examples of big data in industries, why is big data different from traditional data sets, and finally, we will explore various characteristics of big data. Let's first look into what big data really means. Big data is a blanket term for the non-traditional strategies and technologies needed to acquire, organize, process and gather insights from large data sets. Gartner has defined big data as big data is high volume, high velocity and high variety information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision making. When we look at the literal meaning of big data, it means the data that is big. Big means something larger than normal. So, we need to know the normal size of data in order to understand the sudden hype of big data. Let's look at the hierarchy of data size. We normally use files having size ranging from kilobytes to gigabytes. We use kilobyte size for small documents, megabyte sized files for pictures and gigabyte sized files for high quality video. So, big data means data that is larger in size than gigabytes. Now, the big question regarding big data is, do we generate data sized more than gigabytes? The answer is a big yes. Twitter generates every second on average around 6,000 tweets, that is around 500 million tweets per day. In Facebook, around 4 new petabytes of data are generated per day. It includes users' photos and videos. Google currently processes over 20 petabytes of data per day. Just imagine the amount of data being generated every day in various industries. On an average, Google now processes more than 40,000 searches every second, that is 3.5 billion searches per day. Now you would appreciate the term big data. This sudden explosion in data is due to the large amount of data exchanged in mobile networks, huge use of social networking and data produced by sensors. So, the data produced per day is now more than the data that was produced per year in the past. We also know that data storage capacity is doubling every year. With a large amount of storage available, we can store this data, but the important concern here is why to store this data and is the data relevant? We should understand that the data is useful only when we get some information out of it. We can process this data to provide us some inputs for any decision making task pertaining to a real world scenario. Now we can say that though big data is a buzzword for huge amounts of data, the big data concept is really centered on data processing methodologies that can handle huge amounts of data. So, the issue is not the amount of data, but the approaches that can provide effective and efficient data processing of huge data. The real problem is that our traditional data mining or data processing approaches are not suitable for handling this large amount of data. Traditional approaches may take a long time, that may be days to months, to process this large data. So, we can summarize big data problem as huge size of data in terabytes, inability of traditional data processing approaches to handle data this large. Hence, big data is large data sets. Big data is the category of computing strategies and technologies that are used to handle large data sets, and big data is extremely large data sets of varying types of data, structured, unstructured and semi-structured, that can be collected, stored and later analyzed to provide insights for organizations. Structured data is the data that we handle in database management system. The data has predefined structure and schema. Handling this kind of data is easy since we know the overall structure of data. Semi-structured data deals with data formats such as XML, JSON, etc., which has got some structure associated with it. In contrast, unstructured data deals with the data that has no predefined schema. Online comments, tweets, etc. belong to this category. Big data deals with all these varieties of data. Big data analytics aims at exploring approaches that can process terabytes of data at very high speed. Big data analytics is the process of storing and organizing and processing huge data to discover useful patterns and information. Typical data processing applications store data in relational databases. So, the data will be structured. Data that is not structured is converted to required format and is stored. This happens daily or weekly. Data processing tools access this data and generates reports and analytics. So, the typical features of traditional data processing approaches are gigabytes or terabytes of data, structured data, centralized database, relational schema and interrelationship among data. But in contrast, big data is more than TBs of data, unstructured and semi-structured, distributed database, flat schema and not much interrelationship among data. Big data is gathered from different sources and data can be in any format. The data can be sparse and unrelated. So, traditional approaches are not mature enough to process big data. The basic requirement for working with big data are same as the requirements for working with data sets of any size. The massive scale, the speed of ingesting and processing and the characteristics of data that must be dealt with at each stage of process present significant new challenges when designing solutions. So, with that note, we move on to the various characteristics of big data, popularly called as the 3 V's of big data. You can actually now pen down the 3 V's of big data, that is volume, velocity and variety. I hope you noted them down because these are the important features differentiating big data from normal data. The first V of big data is volume, the amount of data that is very huge. As mentioned earlier, data generated by the internet transaction, social networking sites, mobile devices and sensors, etc. is in the range of terabytes. The sheer volume of data presents challenges at each stage of processing and storage life cycle. This makes it really important to use cluster computing. We will be dealing with cluster computing later on. Second V of big data is velocity. Every day, terabytes of data is produced and hence the speed at which it should be processed is also very fast. Data is frequently flowing into the system from different sources and is often expected to be processed in real time to gain insights and to improve decision making. It also requires robust systems with highly available components to guard against failures along the data pipeline. Third V of big data is variety. Big data is largely unstructured. As data is gathered from different sources that are heterogeneous in nature, data can be gathered from systems like application and server logs, from social media feeds and other external APIs, from physical devices, sensors and from other providers. Big data needs to handle potentially any data regardless of where it's coming from by consolidating all the information into a single system. The formats and types of media can also vary significantly. Rich media like images, video files and audio recordings are ingested alongside text files, structured logs, etc. I hope you have noted down the 3 V's of big data. If you have not still noted down, please do it now. I'll repeat that the 3 V's of big data are volume, velocity and variety. Additionally, big data can be characterized to have following V's: veracity, variability, value. Veracity is the first one. The variety of sources and the complexity of processing can lead to challenges in evaluating the quality of the data and consequently the quality of resulting analysis. Next is variability. Variation in the data leads to wide variation in quality. It may be necessary to identify, process or filter low quality data to make it more useful. The last one is value. The ultimate challenge of big data is delivering value. Even though the system may exist to process big data, but may be complex enough in order to use the data, and extracting actual value can become difficult. Now, we have seen additional 3 V's of big data. So, now you can note down the 6 V's of big data. They are volume, velocity, variety, veracity, variability and value. Earlier, we had mentioned that with the sheer volume of data, cluster computing plays a major role in processing big data. Let's understand the concept of cluster computing. So, what is cluster computing? Cluster computing is the term that refers to a set of computers connected on a network that performs like a single entity. Each computer connected to the network is called a node. Cluster computing offers solutions to complicated problems by providing faster computational speed. Cluster computing provides transparency, that is, connected computers execute operations together, thus creating an impression of a single system. So, why is cluster computing important for big data? Because of the quality of big data, individual computers are often inadequate for handling the data at most stages. To better address the high storage and computational needs of big data, computer clusters are a better fit. Big data clustering software combines the resources of many smaller machines. Now, let's understand what are the benefits provided by cluster computing. They are resource pooling, high availability and easy scalability. The first benefit is resource pooling. Resource pooling allows you to delegate control over resources of a host or a cluster. It is the aggregated physical computer hardware like CPU and memory as well as other components. The second benefit is high availability. It performs regular checks to make sure each component is working properly, and if one fails, switching it out for one that is working. Cluster computing ensures even if one or two nodes fail, the data for processing or analyzing will be available. That is, even during failures, the data can be retrieved from the cluster. The third point regarding cluster computing benefit is easy scalability. Cluster computing is able to handle a huge volume of workload or expand in the response to an increased demand for database access, processing, networking or system resources. Hope now you appreciate the term big data. Big data is the category of computing strategies and technologies that are used to handle large data sets. Big data cannot be processed using normal data processing applications. We have also seen the 6 V's of big data that make it different from normal data. We also understood the importance of cluster computing in big data. In the next video, we'll explore Hadoop, the framework that is suitable for storing and processing big data.